gentlemen, the show is about to start in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Good morning, everyone. Welcome to an unusually Sunday morning live unboxing here. For those of you who do not know me, my name is Liam. This is the AstroPrinter channel. I just want to say hi to everybody who's all been out there. So a few people have been hanging around for a while. So Chris Mink, you've been the first on this morning. Congratulations. Good morning. How are you? Let's see what else are. Louise, how are you, Louise? Good morning. Let's see. Sergio HVAC. Good morning, Sergio. How are you? And Jerry, thank you for the like and subscribe. Yes, if you have not already done so, not already liked and subscribed, please do so now. Thank you. Let's see who else is out there. SPC 3D. Good morning. How are you? So, how is everyone doing today? And please let me know if the audio is good. Okay. Please send me a message in chat. Let me know if the audio is good enough, or as good so you can hear me clearly, and video. Anne, good morning. Oh, sorry, good afternoon for you, Anne. Because you're in the Netherlands, I believe. Welcome to another live unboxing. Actually, I have a couple in a row for you. So we'll have one this week, and I have a different one for next week. So we'll talk about that later on. Hey, i3D Cape Town. That is Jacko, I believe. Good. So how are you? And I know, Louise, you're in the UK. I know it's mid-afternoon for you also. And just in case you're wondering why I'm staring down here at the floor, I have a large screen right here where I actually have my video feed, or my chat feed, so I'm watching it over here. Hey, Jeff, how are you? Everyone's saying hi. So is the audio good? Jerry says it sounds good, okay, and the video sounds good. Okay, so this may not be a very long unboxing because there's apparently this is an easy machine to build. We're here to do a live unboxing of the Comgrow Robo CNC Router. Now, it's a desktop router. It is 3018 dimensions. If you want to find out about the details of the router, there's the Comgrow link is below. In the description, and also the link to it on Amazon is below in the description if you're looking at pricing and so on. They have a few different configurations of this. So the different configurations are, this is the 3018, just the CNC router. That's it. There is a version of this that comes with a diode laser, so you can actually do laser engraving on material as well as CNCing just by adding on a diode and plugging it in. And there's also an added option for this of a rotary device. Now, the rotary device is not for the CNC. The rotary device is only for the laser, because basically the weight of the material sits on the rotary and it moves, it rotates around. And if you have, you need torque for a CNC. Now, I'm sure with a bit of creativity, you could actually make the rotary to do rotary CNCs on this machine, but as it stands, it is not designed for that, the rotary device. But it is available in 3 different configurations. Okay, okay, Jack, all good, excellent. All right, so let's not waste time. So let's do let's do the close-up. So this is the machine we're here to see. Now, what's a lot of 3018s you'll see out there from Sane Smart and a couple of others. The dimensions are the same, which is 30 centimeters by 18 centimeters. Or 300 by 180, but most of them have the x-axis being the longer axis being the 300. This one has the long axis as the y-axis, and the x-axis is a shorter at 180 millimeters. Now, that doesn't really matter because you can just flip your part around if you want it longer in one way than the other. It doesn't make a difference. It's all about how you orientate it once you understand the machine. Matt German, hey, how are you? So, let's get to unboxing this. I'm going to leave it in wide cam for a lot of it because it's going to be taking up a lot of the space here on the screen, and I'll switch over to the close-up cam when we need to. So I like to use this for my unboxings actually recently because this came with my JG Maker Artist D. the IDEX printer, and it's really sharp. And it's really good for unboxings actually. It's sturdy. So or we're using a blade. I don't need a blade because this thing is so sharp. There's no point. So if you want to learn a little bit about it, so what we're going to do today, we're going to unbox and set up, and I'm going to do a first print now. I know Jerry at 3D HP has one of these, and he said there was no real test files. So I decided that I just created my own little test file using Easel, and you do get 30 days free with Easel. Even you initially sign up, it's paid after that, but it's a good place to get started. So I just created a simple one in Easel, and I'll show you the file. I'll share my screen in a while when we get to that, and I'll show you what I did in Easel, and then I'll bring you over, and we'll show I'm using Candle to actually send it to the CNC. So let's have a look what's inside. Great. More foam. So we have an instruction manual. Let's see. You see, it's a nice machine. It's a nice. So the x-axis being here is a shorter axis being 180 millimeters, and the y-axis is 300 millimeters long, which is opposite to some of the others that are out there. Just having a quick look at the instructions. Tells you what operating systems you need. It tells you all the components. It shows you the assembly instructions, which we're going to follow. It shows you there's a driver to be installed to communicate. It gives you all that information. It even gives you the pinout of the board, which is nice. I think more companies need to do that. It then shows you how to determine your COM port for your CNC, which is important for communications. It teaches you, which one is it? Oh, this is Candle. It explains to you Candle, a little bit about Candle here. Hey Gary T, how are you? Welcome. There is an offline controller for a hand controller, so you can actually slice in a machine in your computer, transfer the file to an SD card, and actually run it off the offline controller. So it looks like a little game joystick. You see it here. And then it gives you the dimensional details of your CNC and how to set it up. And it also has a Z-probe. Now we're not going to cover the Z-probe here, but I'll explain what a Z-probe is in a while. You don't need a Z-probe, it's a convenience thing. I have other CNCs. I have another 3018 like this, and that's a different manufacturer, and it has a Z-probe. I've used it about 5 or 6 times. The Z-probe is nice for convenience, and especially in a large CNC, it's great. But in a smaller machine, you don't need it. And I normally use the paper, like you do with a 3D printer. I use the paper and test for leveling. I just find it easier that way. So let's see what's in here. Okay, so we have more foam, and we have the adapter for the laser, apparently. Let's see what's in here in the box. Okay, power adapter. We will need that later. All the rest of that is for trash. I have my spindle motor. Actually, let me show you the inside, it'll be easier. Start off with that. Everything is well packed. So the spindle motor was here, and the adapter for the laser was actually in the top. And I do have the offline controller here, which is nice. So we have our spindle motor, which is not marked positive or negative. It should be, but it's not. But we can figure that out because I know how it should rotate. USB cable to communicate with your CNC. You absolutely must have that. Our Z probe. And as I said, I'll explain that to you later on. I need my instructions out of there. a whole pile of brackets and so on. These are probably, there's 4 of them. These are the brackets to hold down your part. So we'll get to that later. A nice Allen key set on a ring, which is nice. I'm probably going to use my own Allen key set because they have a longer reach, but that's nice to have it on a ring. Set of nuts, T-nuts and bolts. A nice set of end mills, actually. There is some, I think they're V-carve, and then we have flat end mills. I'll explain the difference between them later on, but it's a nice little packet. And then I have some rubber feet by the looks of it. More nuts and an Er11 collet, and I'll explain about the collet later on. And I want to add some more information. You have an SD card and SD card reader. What else is in here that's loose? Okay, these are the sides and the stands for the CNC. They are acrylic. A brush for cleaning off. We won't be using that. I'm actually going to be using a vacuum. I prefer that. Our hand controller set, which is our little, like a little joystick. Oh, the button came off. They're only pushed on anyway, so it's okay. I caught it with the cable. They just push on. Be careful, because if the cable gets underneath those, they just pop off. But they do push back on. So this is the hand controller, which we won't be using today. And then foam. This is my X axis and Y gantry. So this is your X motion, and this is the Y gantry that moves forward and backwards. So let me put this out of the side here for now. I need a space until I get this space out. And then last but not least, your Y gantry and base of the printer, of the CNC, and your print bed, or cut bed. So let's get rid of all of this. Alright. Let's see. I have super early version of this one. Yeah, Jim. How are you, Jim? Actually, yeah, I've seen a few other people who have had them, and they've had success with them. I know you had issues with yours, and you're not the only one, because they were really early beta versions. So let's see how it goes. But yeah, I know there was some quality or assembly issues with the initial versions that went out, but they were early beta versions. So let's see how this goes. Let's see. Yeah, Jerry, you're correct about it not starting from it. It is generally you home a CNC to say this is where everything begins. It's the far corner, and then you bring the part out and you zero over it, and you run your part from there because you zero it on the piece. But yeah. I don't know if there's a way to fix that. In larger CNCs, you can actually fix that, where it actually will print from home. But sometimes I'll have to spend some time looking at it to try and diagnose your issue that you've seen, Jerry, because yeah, it's ideally it should go from home like a 3D printer, but it doesn't. You have to bring it out over the part and you zero there, and then that's how you do it. And that's what we're going to do this morning. So I'll be demonstrating that. It's easy enough to do. It doesn't really add much to it. So I'm going to get out the instructions. I know, a 3D printer, I don't follow instructions, I know. But when it comes to doing a CNC, I will follow the instructions because you know why? It's the right thing to do. I know, you heard me say that out loud. I know. So, let's see. Wiring schematic. Does it have any assembly instructions, really? Not really. The instructions are very basic. Assembling stuff. Okay, so that's this. We need to turn this around because this is on the front, which are emergency stop, which is important, right? This is, let me get the close up here. So in the close up here, there you go. So we have this to move our axis, our y axis forward and back, but we have an emergency stop in case anything goes wrong, and you have to release it before you start again. And let's see what else they have. So let's get out some bolts, and we start putting this baby together. Thanks for your confidence, Jerry. Well, by the way, for anybody who's interested, I'm still waiting on that new main board for my CR10 Smart. It has not arrived. Apparently it's shipped, and it's somewhere out there in the ether, somewhere lost. And eventually it'll find its way home to me at some point, I'm assuming. So I have 4 of these bowls. I have 8 of them. Okay, so these are the bowls that they're flat-sided on one edge. Let's see, we'll show here, and that's so they fit into these. They don't rotate, even though they do. But that's what the idea is, to fit into these for you to hold on their part. I'll get to those in a while. So let's get the legs on this first, because I don't want it rocking around, being noisy and all that vibration going through it. Okay, Sergio, see you when you get back. So let's get on these bolts, and I said I'm going to use my own Allen set. What size are these? Okay, I'm guessing 3 mils. I like my own this Allen set because it's actually longer reach. So we just get the base on here, these legs on. They just dampen down some of the sound, some of the vibration, and it means I don't have to listen to the metal sliding on and tearing up the wood surface of my table. Hey Sergio, yeah, that's a good idea, Jerry. I think Sergio should get monsters for everybody and share them around. I think it's a great idea. Sergio, you have my address. You know where to send it to, right? It's a bit of a drive for you, but you can send it by post. I'll accept that. Just not the USPS, because USPS are notoriously bad recently for the last year or so. But so not USPS. Okay. Let's get our X gantry. And let's see, that should go on. What bolts do I need to use for that, first of all? So there's a whole pile of bolts in here, and we have a collet. I'll explain the collet in a while. So I need 6 of these bolts that are short. Actually, I've noticed one thing, that their setup instructions are weak, but it is what it is. So I need 4 of these at the back. Just probably using these T-nuts, I'm guessing. Let's see, how many do I need for the side? I need 2, 4, 4, 6. I have 8 of these that use the shorter bolts, and then I need 6, 2, 4, 6. I got 10 of the others. So I need M5 by 12s for there, and I need N5 by 10s, which are, I'm just checking the instructions, 1 second. Put the small window up top. Sure, if for the close-up, I can do that. 1 second. You mean like that, Jerry? Let's see what I have here. N5 by 10s. You want me to? I can. Well, make it go away is easy. I can just do the. I can just do the wide field. So tell me what you want to see, Jerry. Do you prefer the wide view, or do you want us to close-up camera only? Let me know. We have the power to make stuff go away if that's what you want. Whatever works for you, you tell me. These things are a pain in the neck to get off. This paper covering. Close-up is just good. Okay, I can leave it on the close-up camera. Sure. Jerry wants grind shots. Jerry can get grind shots. Okay, so this is going to go on. Let me show you. I'll put this aside for a moment. This is going to attach using T-nuts along the side here and using these openings here at the back to screw on the acrylic to frame the unit. I'm going to make sure I'm getting the right items. So these have T-nuts, and I don't know why they have T-nuts, because yeah, this is telling me to use all M5. I'll put this on loosely just to get it in place. I'll peel these off because these have to go on the sides. Okay, this is where it's really handy to have nails. There we go. And I don't have any nails. So if anyone have any questions about this machine so far, please, or any questions at all, please let me know. This acrylic covering is a bit of a pain to get off. I will notice one thing. They never included any sample pieces of wood, which was kind of interesting. Which I'll have to figure something out for that, because they normally give a sample piece of wood with most, and I didn't see any samples with this. So I'll have to go and find some sample pieces somewhere. we have to put on these T-nuts. Oh, I think I put the wrong T-nuts in the back there, but that's okay. I can change that in a moment. I miscalculated a little bit. I need to put the longer bolts in the back, and I'll replace these with the, take out the short ones that are in there. So let's see. So this is just going to go sliding in to these V-rails, the rails on the side. Like so. You just put one up against the other, and then you bolt it in place. And don't over tighten these. Remember, it's acrylic. Don't over tighten it. If you over tighten it, you'll crack it. So it should just grab it and leave it at that. So I need to take these off because I made the mistake of putting in the wrong bolts. It doesn't actually say in the instructions, so you'll have to. It's probably a 3.5. No, it's a 4. Okay, I'll just switch these out for the heavier versions. That's what they want. Because I need these smaller ones for the side. I don't know why they changed them. They could have used the exact same all the way around, but they didn't. Let's see how this goes. So as I said, the details of this are actually below. I think just the CNC alone is $230, just for the CNC unit, just for the Robo unit, no laser head, which is actually quite a good price. There are other CNCs out there that have other functionalities, that have that are also good machines that have the slightly different orientation. I know Jim had some issues. I know Jerry had some growing pains getting his operational, which is why I decided to do a live to try and get it up and running. It's because anyone who's not used to CNC, excuse me, I'm not ignoring you, I'm trying to get this off. Anyone who's not used to CNC, it's a process, right, of learning. It's like when you first time you get your 3D printer, and it's by doing it this way. Now I'm going to when you start out, they do come with Candle, which is a fine application. Don't get me wrong. Candle is a good little application for CNCing, and it's free. They also recommend using Easel. Now Easel is not free to create your initial design, but it's free for 30 days, and it's a good place to start out. Oh, Comgrow is sending Hobby Lobby Rich a Comgrow Z1 to test. Nice. Yeah, the Comgrow Z1. Actually, I have one of those, and I'm going to be doing an unboxing of the Z1 next week. So if you're, I got 2 machines in this week from Comgrow. I got this machine in, and then I'm the Z1. So we'll be doing an unboxing of the Z1 next Sunday. I'm not doing Saturday mornings this week for the next couple of weeks. The reason why is I'm doing some stuff with my son out at in Detroit. We are doing some community stuff for the poor. We're doing some soup kitchen stuff, and it's good for him to be involved in that. So we are going to be doing that for the next couple of weeks on Saturday mornings. And if you hear my voice a little bit scratchy, that's because I'm standing out in the freezing cold on the street and on Saturday mornings. But I was yesterday morning. So it's because the cold weather. It's winter here, so or when they're starting anyway, at least. Get these orientated a little bit. So we're doing some of that, and because of that, Zolan, I need to find some companies that will send me gear. Well, get online, Zolan. How dare I not spend time with you? I'm spending time with you now, Matt. What are you complaining about? It's not like I'm your girlfriend or anything. You got one of those. Go talk with her. Okay, so this is the back of the machine with the motor in the back, and this is the front of our machine. So our x-axis will bolt on in this orientation using these heavier bolts. Yeah, Easel can be used for free for the first 30 days, and after that you pay for it. And it's a nice software. Now there is laser, what is it called? Universal G-code sender, which works great. Again, it's a learning curve, but once you learn it, it's actually really good software. So the Universal G-code sender is what lots of people do. So if you have, if you don't want to pay for Easel, you can use Universal G-code sender. Candle, and you can also use a lot of what you can, like if you're designing, you can design in Fusion, and Fusion will export an NC file, and the NC file type that Fusion will export is actually the same, is the file format, is basically G-code, right? That's what Gerbil runs on, is G-code, and the Universal Fusion will export that as part of the free version of Fusion 360. Now, there is a bigger learning curve in learning how to do your cam software, or your cam part or slicing part. Or in CNC we call it tool paths. When you're doing your tool path in Fusion, there's a bit more involved. You have to learn a little bit more, but it's not super hard. Once you do it a few times, it's easy enough to set up. Okay, so here, connecting our y-axis to everything else is this one. It looks like the only ones that will fit together. This is my x-axis stepper, which is right here. So I plug it in. I'm surprised I didn't have that already plugged in because it's all part of the one gantry. Let's see, as far as I know, listening, but I need to get back to trying to hang a... Okay. Dipole. And we have a whole pile of connectors because our control board is here. So we have, let's see what we have here. This is our, I'm assuming on the back here, it's the only one that has that type of connector, is our stepper. We're here. It's keyed, so it'll only go on one way. And our Z motor, our Y-axis motor, goes on here. So let me see if everything's connected up. And since Jerry has one of these, he's going to keep me honest. Well, kind of honest anyway. Let's see. Plug this on. That clips on nicely. That's fairly tidy. I'll probably pull it up to make it less slack. I should tighten that a little bit more. And I would probably want to mount this over here, which is why I have an extra connector. But I would want to mount this slightly different because I don't like the way it's what I'd probably like to do is use this. Oh, this is adjust. So this adjust, I'm assuming, adjust. Oh, we have a whole pile more cables here to do. So let's see what we have. PWM. That's, I assume, is for the laser. Oh, that's the laser head. So there's two connectors for the laser. Jerry, you didn't get the laser in yours. The instructions are a bit light on the cabling, but it's okay. Let's see, red on one side. Z-axis switch. Okay. So we have a whole pile of switches over here. This cable is for your Z stepper. Let's see what else we have. We have the positive and negative for our motor when we install it. That's a laser, which we're not going to be using. PWM. This is a Z end stop switch. Here. This is another Z. Let me see what's on the side. Oh, we have another end stop. Okay. So we have a second Z down limit switch, which is oriented a bit weird, actually having to run the cable from the bottom up into it. Actually, I think that one should be the bottom one. And this is the top one going by cable length. Sorry, I'm just wiring up the side here. I'll show it to you in a moment. It's a bit hard to do when it's pointing away from me. And then we have our two power, laser, and PWM. So the power and the laser, two for laser, adjust for probe. Yeah, two for the laser, which is power and the PWM. And then we have our control, our power for our spindle. So let me show you what I did. So there's a long cable here, which is, this is a bit weird that we'd have the cable coming out underneath. That would actually be better if the cable was actually in the front here, so it wouldn't get in the way of the print. It probably won't get in the way of the spindle, but still, it's kind of not the tidiest way of doing things. It's kind of hanging below the work area. I don't like that's. I would probably move that either to be in the front here or at the back here. This is fine. The rest is okay. And then we have the spindle. Now on my spindle, it's not marked positive or negative. There is no red or black marks on my spindle. So Jerry, I'm going to ask you I can figure it out. Hey Dennis, how are you? I want to ask you a favor, Jerry. On your laser, on your spindle, there is a gap on one part here, on the wrap around your spindle. Is that pointing? Based on that, which one of these is the positive and the negative? Because you have yours up and running, and mine is not marked. It should be, but there's no positive or negative markings on mine that I can see. So since you have one, Jerry, I'm going to ask you. There's no red dot whatsoever. Oh, I know. I think I figured it out. I think there's actually not a red dot on one of the plastics. One is extruded. There's a positive symbol on one. Looks like maybe. Okay. This one is positive. It looks like. Okay. So. Yeah, it wasn't very clearly marked. So we're going to loosen this. And this is where we put our spindle. This this open area right here goes towards the front. Now, this spindle already has a collet inside there. If you look here, there's a collet already inside. Now let me explain what a collet does, if you're not mechanically minded. Basically, this is another collet, and what a collet does is, when you put your cutting tool in here, what we call an end mill, right? It basically squeezes from all directions. When you tighten it up, it gets squashed, because it gets squashed up into the base. Now, I would highly recommend that if you do get this, you start out, you're going to go with 1/8 inch bits is what you get, 1/8 inch end mills. Our HDD platter is just coated. What do you mean by HDD platters, Jerry? Yeah, I know if it's wrong, it'll spin backwards. I know, and I'll check that. But I would highly recommend that if you want to do some more beyond using these small end mills, which are 1/8 inch, or the 3.7 millimeter, I believe they are, I would recommend you get a collet set that allows you to use larger end mills if you start to use this more and more. A collet set, they're not expensive. These are Er11 Collets. Let me go to the wide screen for now. So these are Er11 Collets, and actually I'll do this because I want to do some close-up. And in a collet set, you can get a collet set pretty cheap on Amazon, an Er11, and the different collet sets have different bores in them, right? I'm sorry, welcome. I'm just glancing over. Forgive me. So what do you mean by HDD platters? So the different bore would dictates the size of the end mill you can take. So this is a larger bore. They're different. You can get a collet set pretty cheap on Amazon, and what it allows you to do is use stuff like, if you see how small these are in the diameter, you can actually use larger end mills like this. So it gives you the flexibility. Now these are ball end mills. You can tell that by the end of them is round, and these ones are flat on top. So that's a flat end mill, and these are V bits, which I'll show you in a moment. And you can also go up to using much larger 1/4 inch or much larger end mill bits like this. So you can actually, now you have to slow down your cut speed, but you can use larger end mills like this if you have a collet set. That's if you started getting into more and more creative stuff. I have these because I do a fair bit of work on my other CNC that I have. So collet set is cheap. End mills are not as cheap, but they are. It's worth your while if you start to do larger end mills are great if you want to do a large area clearing. The larger end mill will actually clear the area faster for your rough cuts, and then you go over to the smaller end mills to do the finer detail cuts. So it's got a collet. We're going to put it into, so this bracket here is always inside this. I need a bit more space to squeeze it in. Yeah, it's a bit of a, let me turn it towards me. It's easier when it's facing me. And this is plastic, ABS. So you, I would much prefer an aluminum base. This is tight to get in here. Things I might mention, I understand you know this, but oh yeah. Go ahead, Jerry. The more information we have out there, the better, right? This is a very tight fit. See, this would be better, well, in my opinion, if damn, that's hard to get in. I wonder if a good book is in better from underneath. Let's see. No, that sleeve is moving. Oh, okay. Now this is a really tight fit. That's a good thing, but it makes it painful to get it in there. You know what? I'm going to pry this open to make the fit easier. You know what? I'm going to go without that because it doesn't fit very well. Let's see how well it fits without the collar. No, collars needed. Okay, let's refit the collar. Okay, it's really hard to get this on. It'd be nicer if this was actually attached on both sides, 2 bolts in the front, because I'm trying to, it's hinged, and I don't want to force it too much to break this, but it'd be nice if that was actually would come out together and then re-bolt back on again. It would be a better overall solution. I need to use a wrench to pry this wider. Get it to fit. Damn, to make this hard to put together. Back in the day, I was given a new weed eater because I spun the wrong way. So this is not going together nicely. This does not like to be together. There's a bit of a ridge there. It doesn't seem to like to go in there, even though I'm prying it wide open. Got it. Okay, I need to rotate it. Let me do it this way so it's easier to get my hands on it. So that's a bit painful to get in place, but it is what it is. And I don't care about the orientation of this so much, but I do want to spin it a little bit with some leverage. There we go. Now we are where we want to be. Okay, so using the gap here, you can't really see that. Let me raise this up a little bit. Using the gap that's here in the collar, I use that to get it in there by the slot at the side, and then I spun this around to make it fit. It's not what they want, but it's hard to get it in otherwise. Yeah, I actually used a wrench that came with it, so let's push that down more because I want more of that collar in there. The collar should be embedded, and just the vents on top should be these vents that you see. Let me put it over here so you see. There's vents along the top here. These vents need to be above the top of this. Make sure this is tight, because this is holding your spindle. Hey Chris, how are you? Tighten this slowly, you don't want to crack it, because it is plastic. It'd be nicer if it was metal, but it's not. I'm going to go back and check the box in a moment to see if there's any sample parts in there. I'm worried about over tightening that because it is plastic. So let me find my positive on that side, negative on the other, so positive. So all we do is plug these in here. Positive slots in over this side. Negative goes here. And because I'm not using a laser, these are unused. So we should be in place. Now, just give me 1 second. I want to go back and check the box to see if there's any test parts, because there's none. They didn't give me any samples, which is kind of unusual. 1 moment. No samples. Which is kind of weird, but okay. Let's get this plugged in and get it working, and I'll dig something out that I can use as a sample. Some old piece of work that I have lying around here or something. So we have a power brick. I don't have a spare cable, unusually so. We can get up and running. Switch yellow cover. What do you mean by stop switch yellow cover? What do you mean, Jerry? You can explain what you mean by stop switch yellow cover. Is just, I'm assuming, is a Z Pro. Yeah, we're not using that. So Jerry, let me know what you mean by that. Power is at the back. One, 10, 220. Okay. Mine had a ring to go around the stop switch. There, yeah, I don't have anything like that. No, I didn't have a ring to go around about the stop switch to prevent it from being hit. No, I didn't have that on mine. So I need to find a piece of material. But before I do that, I'm going to take out one of their flat end mills. And I'm going to put in a flat end mill into our setup. So let me show you actually on close-up camera. Let me bring the close-up camera over here. So, flat end mills. The very tip of this is flat on top. Obviously, it's flat end mills. A ball end mill. You see some of these, that are ones I have here, are rounded on top. So that's a ball end mill. So this is used for clearing, and if you want to have a flat surface or very clean flat edges. The ball end mill is for curved surfaces. If you want to get a curved surface, like where the part ends and begins, you want to have it to kind of curve upwards. So the ball end mill is for stuff like that. And since I'm doing clearing, I'm going to be using a flat end mill. And to put the end mill in is pretty straightforward. You just put it into the center of the collet that you have in the base. Some people find it better to unscrew this. Here the collet is installed here. And you just put the end mill in. And be careful, these end mills are very, very, very sharp. So watch your fingers. If you haven't used a CNC before, all the end mills for a CNC are super sharp and they will cut. Don't try and turn it with your fingers, because chances are you're going to reef your fingers. And once it's in place, I can show this. Let's show this here. One to hold, one to tighten. Opposite directions, nice and easy. Make sure it's tight. Okay? Now, it's plugged in. Normally it comes with the power, with the emergency switch in the closed position, pushed in, turn it to release it. Okay, turn it clockwise to release it. And once that's in place, you should be in a good enough position. Oh, the power cable came off. You should be in a good enough position to turn it on. Now, let's hope no smoke. Let's see if the board is lighting up. Okay, I think we're up and running. You don't see anything on it, right? You don't see any indicators. It just powers on. It doesn't actually start doing anything until you configure it. So I need to connect up my, I need to create these brackets first of all. Excuse the noise. But these are the brackets that hold the part in place. So you have one that goes through here, that's a fixed, and then we have a sliding spot. One goes through, you should have 8 of these, 8 bolts. One goes into bolt right way up, which is the fixed leg. And the other goes in there, upside down. So the way it happens, the way it works, they're upside down like this. So the reason why, and I'll show you on the device how it works. You have a part in here. This one, let's see, scroll that in a bit more. I'm going to use this as an example. Can you see that in the close-up? No? Let me turn this around. So, the way it works is, these should be fairly level at all times. So based on the height of your work, you move this up or down, and you loosen this out. And you would take your part, this one goes into the slot. Like so. Let me lower that down. And then this one goes over your part. And to clamp your part down, you would tighten this up. It's a bit too loose. 1 second. You would tighten this down, and this part back here acts as a wedge, and it tightens down, and that's how you hold your part in place. You get it nice and tight, and then your part can't move. And you put them on 3 or at least 3 sides, if not 4 sides of your part. So if it's a square piece, I had 2 on one side and 1 on the other, that's okay, but all 4 is actually better. So that's how these brackets work. Now, the one thing is, these rotate in these slots. This shouldn't. On one of my others, and I'm probably going to do it for this, I'll design a different, I'll actually design a slider that goes into these slots. And that way then, when this is fixed in place, this will never rotate. Because right now it's spinning around in there, and that's why it's being troublesome. Yeah, so let's see if I can find a bit of... I have material I use for one of my lasers that I could probably use on this. Actually, I created my own test file because according to Jerry, there is very, very little, there's no real test files that come with the CNC. And they should include a couple of test files, and they haven't. So what I'm going to do is, what I did was I created my own test file. And so you can run it on your CNC directly. And I will actually share that out to everybody. The G-code file, set up for the flat end mill, the 3.75 flat end mills. We'll share that out for everybody so you can all use it if you do decide to go and get one of these machines. Now, the G-code file, one thing you need to know about it, it is not dependent on the size of your CNC. It's dependent on the size of your material. So a G-code file I created for this machine. When you start off a CNC, you home X and Y and Z, and then when you're done with that, you bring it out and you zero it on your piece. And then in your software, you configure the size of your workspace, being the size of your material, on the software that you're using. And when you zero it on the corner of that, that is its start point. So it doesn't care about where it is on the board. So you can use the same G-code file on any CNC as long as for the right size bit. For 2B drive, SV35 has 2 platters where the Barracuda only has 2. 2 terabyte drive. Oh, you're talking about hard drives. Why are we talking about hard drives? Let me see what he said up here earlier on. He said, okay, why are we talking about hard drives? Because you're talking about Barracuda hard drives and 2 terabyte storage. So, okay. The number of platters on a hard drive and the number of physical spindles in the hard drive dictates the performance of that drive. Because it's the amount, so having big hard drives is not always, if you're just looking for plain storage, big hard drives are great. We're diversifying a little bit here, but big hard drives are great if you just want storage. But if you're not doing a lot of reading and writing to it, if you're doing an awful lot of communications to it, smaller drives or solid state drives would be an easy fix, or more smaller drives rated together, and because you get better disk I/O when you do that. I know it's a bit off topic, it's not related to this, but still, someone asked the question, so. Alright, so let me see if we can get this working. You're watching Tuesday night? Well, you got an answer from both. So let me go over here. I want to test this. Let's do my USB cable. And they're going to link up the CNC via USB to my computer. Now, can you run a CNC without a computer? For Kindle, no. For Universal G-Code Center, yes. You can use a Raspberry Pi. The same goes for slicing, depending on your software configuration. But yeah, you can do it from more than one, from without a machine, Now, in these units, they do come with an offline controller, which I haven't used yet. And this is your offline controller. And with the offline controller, you can actually load in an SD card into this machine. Let me see a closer camera here. You can load an SD card in here. And actually, so you cut your G-code, load the SD card in here, zero out everything using a hand controller, and hit go, and it'll run. Now, you never leave a CNC alone. You never leave a laser alone. You stick with it, you stay in the same room, you watch it. You wear safety glasses when you're using a laser, which they didn't provide. Get safety glasses if you get one of these. You need safety eye protection. The only ones I have right now is, I have ones for my laser. They're green, but they'll do. They'll help protect the eyes. Never operate machinery without eye protection. Oh, you're tearing them down for scrap. Okay, so, actually, let's put on the hand controller and let's drive this to make sure our power, everything's functioning. So let's power everything off. Put on our hand controller. The hand controller plugs into the board at the back. Pretty straightforward enough. Let's power it on again. And I don't have power. It's not working. I'll try a different port just in case the port is bad. I think I have a dead power supply. Let me go plug it in somewhere else. I also don't be too close in case the... Yes, correct, Jerry. You do not want to be near a CNC if the bit breaks. Okay, I got power there, so I'm going to run it remotely from over here because apparently I'm not getting enough power over here, so that's fine. Turn this off again. It's not working. I think my power interface here is bad. I think I got a bad power interface. When I plug it in, I get a power light. When I connect this to the CNC, it starts flashing. Watch. I think actually, I know what's wrong. I think the power connector on the back is actually loose. So let me disconnect everything here and do the unthinkable and flip it on its side so I can see underneath. And I think this is making weak connection. Let's try it again, as is. Off. Okay. It's getting power outage. It's going to be a very short show. If I might be able to fix this because I think I know what's going on. I think one of the little pins inside. No, there's no. This is a 110 220, so there's no switching. This is a dual power brick, so there's no switching involved. But I think I know what's going on, and I think I have an idea of how to solve this. I need a small Allen key. Yeah, I did say it was going to be a short show. I didn't think it was going to be this short, Louise. That was not the intent, to find something broken. So let me just have a look. I think this is slightly off. It's a loose connection, I believe, inside in the back of the machine. So I will have to get it replaced. But I think I can tweak it to get it working today. Let's see if that works. I think I need to change the power connector on the back here. Maybe not. Let's see. It's fine until I hit the power switch. Oh, one thing I need to check. Yeah, I'm about to check those dip switches on the side, Jerry. That's exactly what I'm going to do. There are some dip switches on the side of it to change from laser mode. And maybe that's what I need to check. Let me see here. Because the power brick is showing positive, and it powers up. But the dip switches may be the issue. While Jerry's quickly checking his, actually I don't even see instructions in there on the dip switches. Jerry, they're both in the up position right now. Yeah, they're both in the up position. That's exactly what I have. So what's happening is when plugged in the power brick is showing green, but when I turn on the power, it flashes very, very dimly. I'm going to set it up on USB anyway. Let's see if I can get it to talk to my printer. But it's the fact that the hand controller is not coming on, that could be something disconnected somewhere along the line. And I'll have to take the cover off to investigate that. Let's try it again. Yeah, the hand controller's not even coming up. I think I may have a DOA machine. Once plugged in, yeah, I don't have. It's either that or my power brick is bad. Let me get a multimeter. One moment. Okay, let's try this again. Multimeter. We'll do a test on the voltage out from the power brick, and if that works, then we know it's the machine, and then I'll have to do a bit of investigation as to why. So, what is the power alignment on this? Positive in the center, and it's 24 volts output. So, turn it on. Voltage. 200. The positive is the center. 24 volts out, so that's coming out good. So we know the output is good. Let's see if the 24 volts is coming inside to the board, which I think is the issue that we're seeing. Let's tilt it over. See if I can get 24 volts here on the center pin and then the outer pins. Welcome to troubleshooting electronics. Yeah, mine does dim, so there could be a short somewhere. That's what I'm thinking as well, Jerry. I have a feeling it could actually be. This is going to where. Yeah, I'm not even getting voltage in there, which leads me to believe that it's the connector that's bad, because I should be getting voltage coming through that when it's turned on. Which I'm not. I think the power switch itself is faulty. I'm going to switch it on just in case they got it mapped backwards. Yeah, so the power switch itself is the one that's at fault. It's not. It's a bad power switch. It looks like, or not power switch. Maybe it's a switch. Actually, I wonder if they wired it backwards on the switch. I wonder, did they wire it backwards? Let's see. USB cable, hand controller. Should work with a hand controller. No. Yeah, I think my power switch, my power port is bad, which I'll have to troubleshoot. Luck of the Irish. It's the bad luck of the Irish apparently recently, because my CR10 Smart. Man, this channel's getting as bad as tripods with so many problems. Well, guys, if you haven't checked out, by the way, check out Jerry's, because Jerry has one that works. Check out his channel. He has his CNC working. Apparently, I'm running into a power issue on mine. I think, let me do one or two more quick checks with everything off. Let's see. Let me take off the cover of the main board. I want to have a troubleshoot the main board to see if there's power coming to the main board. I'm guessing not. Where is my guessing it's not working on the board, at the main board. But let's go in and have a look, see if there's any power getting to the main board. Because it hasn't done anything. And normally they don't do much anyway, but still. Until you send the commands to them. But I want to check the power input on the main board to see if I'm getting the 24 volts. I should be. And if not, we'll end up doing another live unboxing some other time. Or if I get it going, I'll just do short videos of getting it functioning. But my guess is where the power port is on the back of the printer, it's bad. The connector is actually bad. Okay, that's just the fan. So we have voltage coming in. Positive and negative. No power. This is, yeah. These are very loose connectors. Yeah, there's no power hitting the board at all. And this is our main power lead coming in. And when this is off, it's green. But when I turn it on, hey HVAC, hey Jerry, how are you, Sergio? Move the pip to the left. What pip? Oh, I'm sorry. All I'm doing, let me turn off I'm on the main screen. What I'm trying to do is it's not powering up. When I turn it on, when I plug in the power brick is showing green light, LED. But when I plug it in on the main board and hit the power switch, it goes from a green light to flashing. And it's not the stop, because I already checked the stop. It's already not triggered. So I know it's not the stop. First thing I untriggered when I plugged it in. So I'm thinking that either on the connection where the power plugs in, which is kind of a little bit loose, so it's not making good contact. But I should be able to make it good contact by moving it. But it's still not working. I'm guessing it is either a loose connection somewhere along the line, which is possible, but there is zero life out of this, because that screen should come on. Air gap. Could be old curmudgeon, could be air gap. So I know the power supply is good. I just checked the voltage in the power supply. The power supply is 24 volts. And it's registering correctly, 24.5, which is fine. So the power supply is actually outputting good power. It's actually something to do with the wiring on the machine. And no, I will not do that. Dum Dum wants to get me electrocuted by telling me to lick my finger and test it. Yeah, so and all the dip switches are correct. So I'm thinking there's a loose connection somewhere along the line of the inside the system. I'm going to have to let me put this cover back on. I don't think it's on the main board. Let me check all the connections on the main board, because they are kind of plug and pray connections. They're not super tight, which is okay, but because they're not going to be moved around that much. But still, let's try again after reseating them. The pixies aren't angry enough. Rewire it. Yeah, I think you might be correct on that. Something is loose somewhere. Oh, I wonder if the fuse is blown. There's a fuse on the main board. No, the fuse looks good. Because this board is fused. Yeah, I think it's something to do with this, with the power comes into the CNC is not right. Not the best first impression, but I think the connection where the power runs in is the problem. The fact that the power supply is flashing. Test, don't guess. I agree. I'm just going by grab the Z1 brick. That's not a. Will the Z1 are the Z1 bricks the same? I don't want to open a Z1 till next week, but let me. I don't think it's the brick. The brick is outputting good power. It's not the brick because I tested the power right here and it's good. It's coming into the machine is where it's not right. So what I'm going to do is I'll have one or two quick more checks, and if I can't figure out what's going on there quickly, we'll wrap things up. I will message our good friends at Comgrow. Let them know what's happening. Let's send them the link. They have the link to the unboxing anyway because I posted on their group last night. And I will do a bit of electrical troubleshooting. My guess is it's a bad contact somewhere. But you're right. Don't guess, check. But I will be checking in a while. And I will get it. We'll get it functioning. And once I do, I will post some videos because I wanted to show some test stuff. But I suppose I can show you that anyway. If you do get one that works, because mine is not working. I want to show you how to use Easel, because you get a free 30 days of Easel when you before you have to pay for it. And I'm going to show you that on my screen, how to get that up and running. And then I'm going to show you how to bring that into Candle and use it. So let's leave that aside for now. I just want to cap off the tips. And I will take care of this in a while. I'm going to share my screen in a moment. So we'll come back to that. Okay, it's not working right now. All right, so I want to show you. I'm guessing it's a cold joint or it's a bad connection, but we can figure it out later. So I want to show you some other stuff. Anyway, well, since we're here, I'm going to share out my screen to you, and I'm going to show you how to using Easel, which is web-based, how to do simple setup to create G-code files to output that you can save out, and then how you import those G-code files into Candle, which is the software that sends the G-code, or Universal G-code sender to send it to your CNC. Okay, so let me just quickly share my screen. Okay, where am I? So screen share, there we go. Okay, so this is Easel. You do get free 30 days of Easel. And what you can do in Easel, in Easel, there's a few things. As I said in the CNC, homing just tells the machine where everything starts. That's all it does, it zeroes out everything. But the main thing, even if you don't have end stops, you don't have to home a CNC. You can fake home them, there's a way of doing that. But what you should be doing is, you need to zero everything on your part. That's where everything matters. So if you have a 100 by 100 millimeter part, and it's, say, 5 or 8 millimeters thick, you need to tell the machine that. You need to tell your software that's going to be creating the tool paths, which are the cutting paths it needs to take, exactly the dimensions of what your, of your work area, and then you apply your image or whatever you want into that work area. So this is Easel, and you do get, as I said, you do get a month. You haven't lost the probe caps. No, I've kept all my probe caps. Yeah, I try and keep care of those because it gets used a lot, as you can imagine. As you just saw, it gets a fair bit of use. But so the way it works in Easel, when you log into Easel, there's a few things Easel really only cares about. You can set the size of. You can go to your machine, and this is generic machine, and I'm going to do you're going to edit the machine settings, and the only thing you really need to care about is your overall work area, because you want to see visually the part. That's all you care about. You want to see, so you make sure you don't make a part that's too big for your work area. So you would set your Y, in this case the X-axis is the width, and narrow, it's 180 millimeters, and the Y is the longer axis, at 300 millimeters. Spindle, if you have a specific router, you can use that, but I'm not. I'm just set it to other because it doesn't care. And I set the maximum speed because I noticed the 10,000 RPM spindle on this. That's all it cares about. If I have a Z probe, I can edit the Z probe in here. There is a Z probe for this. I haven't configured it, but I'm going to skip that for now because you don't need a Z probe. That's just a convenience option, really, on large machines. So you set that up, you hit save, and that saves the size of your. Let me see here. That saves the size of your work area. So it's 180 by 300, and the size of this is the piece of material I'm going to work on. So if I do 100 by 100, that's what I've set it for here. So I go to over here. I set the material. I can choose the material type. It doesn't really matter, but I've chosen the material type. I set it's 100 wide by 100 long, and I said it's 8 millimeters thick. Now, as long as you're not cutting below your material, it doesn't matter. So as long as you're not cutting through, this really is only important when you're doing a cut through. If you just want to make sure that you have the depth so it goes all the way through. If you want to cut the part out when you're done, but in this case, I'm not going to do it. This is going to be set up just to engrave the surface, or a little bit of depth in the surface. So once you have that done, then you do your design. You do your design here. So let's zoom in. And this is just the design of a smiley face. Now, the nice thing about easel is whatever you do over here, it shows you a representation of what it looks like over here. So if I brought out, let's say, another symbol like I know Amanda's not on, but if Amanda was on, and I brought out the unicorn symbol, where am I? Sorry, my mistake. Let's say the unicorn symbol, and I select, let's do an outline of a unicorn's head. So you see the outline of the unicorn's head appearing here. And as I move it around, if I move it around, it updates over here so you see where it is. Now, one thing that's important to remember, if you want to start in the middle job, 00 work on easel. Yeah, you can do that. But if you want to, it doesn't really matter about doing that, though, Jerry, on easel. You can do that but you don't have to. It's all about aligning with your part. But I'll show you in a moment. But we've discussed this, Jerry, you and I. So let's take away that we don't want that for now. Now, the other thing you want to do here is you want to set the bit size. Now, as you see, this is pretty wide area being cut. But if I want to take this away and bring in something that's narrow, let's do Control A, delete that. And I'm going to bring in something that's actually a very narrow cut. Let's say this one. And I want to bring it in so there's very narrow walls. Now, did you notice anything? Did you notice that the part, you don't see the walls, the outline, you only see some of the thicker areas. Here's the reason why. The bit that I have in, which is a 1/8 inch bit, will not cut this narrow a line because the line is wider, or is narrower than the bit can cut. So if I use, instead of using a 1/8, and I will use a 1/16 bit, okay, and I come out here, now I see the line because now the bit will actually mark it for you and actually cut it for you. So it's an important thing about easel you need to understand. And if I get this and I drag it over here, do a select all, and I move it. Come on, just move it to mouse. So the bit, so that's why and sometimes you will see the outline here, and sometimes you won't. So and that's why. So if I use the 1/8 inch bit, which is what I have in there, and I choose a 1/8 inch mill, I cannot cut the narrow areas, which are these areas here and the outer walls. So let's do a Control A. We delete all of that. We'll bring in a bigger part again. Let's say the smiley face again, and I can bring it in with a double line, which means these small thin lines will disappear. Or I can bring it in with a solid eye, or that the eyes stand out. I have to choose a few options here, and I can actually scale it up, and I can do all of this in here, and it's nice. So once this is set up in here in easel, and if you want to center it, you can actually center it. Use these lines here to center the part. Oh, Control A, but that centers all components. So you want to do Control Z, undo that. You can do a lot with this, right? And it's nice, and you can bring in text. You can do the whole pile of different types of text. You can bring in there and so on, which is nice. Now, once the part's in there, and you've set it up, you can use Easel to actually run your CNC remotely from the your web interface. I don't do it. I think I've done it once ever. I don't really like doing that, but you can do that. That's where the carve button option is up here, where you set up and you set the link between your laptop and your web interface to your machine and actually drive it from there. But as I said, I rarely do. I normally just create a G-code file. So once you have this set up, and you can, like, when you select your part, you can actually say the width of the face, the depth of it, and so on. You can edit the points by moving some stuff around. You can modify your cut. This is very important. Your cut depth cannot be more than, in the negative, cannot be more than the depth of your material, unless you're doing a cut through, right? So if I want to do a shallower cut, I'll just move this up here, and it does a much shallower cut. If I want to do a deeper one, it'll do deeper, but it will stop here at 8 millimeters because I told it my material depth is 8 millimeters. So that's important to remember, right? You can do a cutout pocket area. We can actually cut around a space around the part as well if you want to, but I'm not going to do any of that. Okay, I'm just going to set it back to normal. So just do Control Z, undo all of that. Now I can do different areas. I can say I want this one deeper, and this one shallow. I want this one to be at a greater depth. I want the mouth to be all the way through as a cut through. So now you can see that the eyes are different. This is deeper, and then the mouth is a cut through. So you can do a lot in here, and it's kind of cool what you can do with Easel. It is basic, and you can do a lot, but you still can do a lot with it. It's a great place to get started. You have a lot of different shapes over here that you can bring into your parts and so on. So you can be creative. Now, when you're done here, once these are done, you have your dimensions, you have your bit size, you have your cut settings set. So this is where it comes into play, that you need to understand feeds and rates about CNC. So feed rate is the speed the cutting tool will move through the part while it's cutting. If you go too fast, you're going to, if you go too fast, let me go back to the main thing for a second. I'll go back to the screen share in a moment. If you have a bit, let's say this is your cutting tool, and you're cutting through material, this shaft of this can only take so much pressure, right? It's a hardened steel. If it's cutting slowly, it will cut, and it'll do a nice clean cut in most cases. If your travel rate is too fast, what's going to happen is the part is actually going to do this to your bit and snap it off and break. And you don't want to be near a bit when that's doing it. 10,000 RPMs, it's moving at high speed. If it breaks, it's coming your way, chances are, right? So you want to keep away from it. CNCs will not run from corners, yes. Yeah, I'm going to do a bit of testing on that to see if I can get it. I generally don't try to run out of from the end stops anyway. I always bring it out to my part. It's just habit I've done. But yeah, I'm going to see if I can figure a way around that. But so you do not want it to bend and get broken, the part, right? You don't want it to snap off. Let's see, this would be better in the close-up camera. So you do not want it to do this and snap, because it's traveling too fast and it can cut. If it's moving too fast and it can cut, you're going to actually bend and do this to the bit. And since this part is restrained inside the shaft, it'll snap off and go flying across the room. An MDF between 5 and 800, I would say 5 if you want a cleaner cut. It's probably a better rate. For softer woods, you can do it like light pine or balsa or whatever. You can go much faster. But again, the faster you go, the rougher the cut is going to be. Secondly, plunge rate. Your plunge rate is, let me bring that over into your screen share. So your plunge rate. The plunge rate, which is the option here, the second one, here. This is the speed that your drill bit is actually going to plunge down into the part when it starts cutting. So when it moves to a location and it starts going down into the material to start cutting, that's the speed it's going to start cutting. You do not want that too fast. Again, it depends on the material, but you're basically drilling a hole, and then from that hole it's going to start moving. So I leave it at about 200, 250, maybe 300. I might go up to 5 on really soft materials, but it varies. For such a small spindle and a small unit, I probably wouldn't go too fast. The depth per pass, this is also important. it's all about how much materials you take off. So the depth per pass is from your material, each pass, how deep I go into it and start moving. If I go too deep, let's say I have a 4-inch piece of block of wood in there. Not that this will take that, but this is an example. And I want to cut all of that in one go. This spindle will not take that. There's no way it'll take that pressure. I was watching a video last weekend of a CNC path, and you can tell as it was cutting, it was moving, and it was jumping because it couldn't travel, and then it was forced to bite into something that's not and it's bad for the spindle. And it's bad for the machine because it puts strain on the machine as well. And your accuracy goes out the window because you're actually flexing the machine. So, yeah, their depth per pass on a small machine like this, 1 millimeter, 1.5, 2 is kind of pushing it on most materials because it's not designed to take that torque. Because it is a plastic cutting head. The whole head is made of ABS. So, 1.5 millimeters. I would say 1. Harder materials go even less. I wouldn't go into hard materials any more than 0.5 millimeter or maybe 1 millimeter at most. This can do some aluminums, really soft aluminums. I probably wouldn't mill aluminums on it myself. I wouldn't go there. Or for those in Europe, aluminium. I wouldn't put it under that stress. If I was going to do heavier machines, I'd either get a proper material mill, or I would look at doing I would get a bigger and more powerful machine. 1 second. So, excuse me. No, I'm not doing a joke about hydration. I needed something to drink. So, so I would say 1 millimeter is a pretty good for such a small machine. Maybe 1.5. I wouldn't go too much over that. They say now next then is the spindle speed. Spindle speed is how fast your spindle is going to rotate. This machine is maxed out at 10,000 RPM. The spindle speed and the cutting tool is a balance about. There is the maximum amount of speed you should have based on the material and the tool bit involved. 10,000 RPM is fine for woods. 8,000 is okay. I wouldn't go much slower than that. If you ever do decide to do aluminum on these, you really need to bring your spindle speed down. Believe it or not, you want to cut aluminum at a slower rate because what happens is aluminum melts. And the faster your tool bit is spinning, you're actually going to end up. Hey Kate, how are you? If you're going too fast, you will actually heat the aluminum to the point that it will melt because it's got a really low melting temperature, and it will fuse to your mill and actually block up the flutes in your mill, and that way then it's no longer cutting anymore, right? And then all it's doing is getting hotter and hotter and hotter because it's now just friction because there's no cutting going on. And then finally, the one other thing I want to show you. Off to a wedding? Okay, take care. Hey, Jake. The other thing I want to show you here is the fill method. Now, an offset is basically traveling around the part, and that's good for round materials. If you're doing if you're doing some three-dimensional parts, you probably want to do the X or the Y fill when you're doing the not clearing but doing fine detail. And in these areas here, your vertical 5 and 20 degree ramp is when your bit initially goes in to the part. If you do straight, it drills straight down and then moves. Right, and that's great if you want a finished piece in the middle of a board. That's great. If you're going to be cutting off the edges, a ramp in is okay, and a 5 degree or 20 degree is the degree of ramp that the part takes to actually enter and start cutting. Some other tools, like in Fusion 360, you have a spiral option. That when it drills down, it actually spirals downwards to the level and then starts moving. And it goes to an area that's going to be clearing anyway. Hey, Jason, how are you? You woke early for this? I know, yeah. The machine's not working. The power is going to the power brick, but there's something loose along the electronic side that there's no power getting into the main board. So I'll have to do a bit of an investigation later on. So yeah, this is a pseudo tripod one where there's no smoke involved. There's just nothing. There's just no working involved. So these are things you need to know about easel. Now, when you're done with easel and you have everything set up the way you want and the depths and everything, you go to your project and you download the G code, and that creates a .nc file. Okay, so it's not actually .g code; it's .nc. Yeah, the power bit dims, so it could be a grounding issue somewhere on the board, and I'll have to troubleshoot that later on. And once that's done, though, the next thing you want to do is you want to bring that into Candle. Now, Candle is free. And this is the part you bring into Candle. When you import, you just do File, Import, File, Open Files, and then you have there the AstroPrinter test one, which is this smiley face that I created. And it opens up the file. And this shows you your toolpath, and this also shows your start point of your printhead. This is where your spindle will be starting. So since this is in the lower left, on my part, I will be doing lower left on my piece. So if my piece is 100 by, let's use this manual as an example. If my part is, let's say, imagine this is 100 by 100, I will be putting my tool head here to begin. And I'll be zeroing my X, Y, and Z axis here. So use the 0 to move it to the corner of the piece, and you use 0, X, and Y. So you have it right in the bottom left-hand corner, because that's where the spindle is showing here. And then for Z, you'll lower the printhead down slow, the spindle, the tool head down, and using a sheet of paper underneath the tool head, you'll bring it down like a 3D printer, where it's actually touching and scratching. I will do that in a moment, Jerry. Yeah, I'll show the SD card files. You'll bring it down to where the paper and the tool head are actually scratching each other, nice and tight scratch. And that's your zeroing yours, and then you zero your Z probe. Your Z here over here. Now, if you have the Z probe set up, which this is, basically what it does is the Z probe, you measure the height of your Z probe, and you input that, and then by using that, what it does is it knows the offset between this and your material. And your Z probe clips onto your spindle, and it clips it turns around and it comes down, it touches it to measure the distance. And then when you start the job, it knows that its offset is this height and more, so it actually comes down further before it starts doing the cut job. And you can set that up in Candle. And once that's done, and you've zeroed it out, you have your speeds here. Now, the G code is very, as I said, it's very like a 3D printer G code. So the first line, the second line here, M3. If you open a G code file, an NC file, and it does not have the M3S and a number, that means it's not setting the spindle speed of your spindle. And without that, it'll go through the motions, but it actually won't cut anything. And the problem, if you have an end mill in your machine and it does that, you end up snapping off your end mill. So make sure that's always in the very one of the first lines. It's line 2, right? If not, you can manually start the spindle by setting the speed here to 10,000 and click this button, and that will send the N3S1 10,000, which is this command, to tell the spindle to spin up at that speed. And then you can run your file here. And this basically shows your toolpath. So if you see here, this will show you each layer that it's going to cut. It shows you each pass to get your final product. And that's what as it works, you'll actually see the tool head working, and the green areas will turn red to say they've completed those passes. So, yeah, Jerry brought up an idea to show this what's on the SD card, which is kind of like a move point right now because the machine's not working. But we'll have a look to see what's on the SD card. You can't see what? What can't you see, Jerry? This is just the SD card. I'm unpacking it, is all I'm doing. Is the video not working? Let me know. It says you can't see. All I'm doing is getting this ready to plug it in so I can read the content. At least something worked. Just let me bring it up to Jerry and I'll share the screen. Okay, let me max screen this. Delete that. So, the video's fine, okay. Oh, sorry, okay, I didn't have it up high enough, I'm sorry. So, let me share the screen again, and I'll show you Anyway, there we go. What's on the SD card is very little. So we have the user manual, which comes with the machine, which has more detail that's in the manual that comes with the machine. The CNC carving machine, these are shortcuts. Actually, these are all shortcuts. And the control software. So these are links out to get the software online. Okay, so if we go to the Laser Gerbil control software, this links you to Laser Gerbil. There's actually... What happens? That's weird. There's actually no files on this. They're only links. So I don't know what happened there. There should be files in there. Yeah, they only got links. Okay. Well, there's nothing on the SD card. Apparently, just your links, and the links are not even working. Let's see the properties of these links. Yeah, exactly, Jerry. What the hell? There isn't even files on the SD card. There's links to files. I think they were badly copied. That's okay. For me, I don't care, because personally, I don't care. But for users, that's not good. There should actually be files in here, not links. And if you even look at the shortcut properties, they're not even going to somewhere. They're not even links to... They're not even URL links. If that was a URL link to Laser Gerbil or whatever, that's one, or not Laser Gerbil, but also the CNC software. There's not even a test file in here. It should have, yeah, you're right, Jerry. It should have Laser Gerbil, Candle, which I already have on my machine for other CNCs, and the test file, and there isn't a test file in there. So this SD card is blank. Let me reseat it just in case. Let's see, USB drive. Oh, there's two files in there, and I know my software protection does this, but there's not in there but URLs. So even the SD card is blank. Okay, you'll Dropbox them. Well, I don't need them. Really, I do not need them. I was going, if they had a good test file in it, I was going to use it, but you told me they don't. And the test file apparently is just a square, which is kind of pointless. I created a simple one, which was this smiley face myself last night, and I tested it on my other CNC to make sure it worked. Actually, do I have where did I put the blank for that? I'm trying to remember where I put the blank from that one that I cut yesterday. I probably threw it out, maybe. Let me check one moment. Yeah, I probably don't. Well, I created this yesterday and I tested it on my other CNC. Headphone alert? What headphone? No, I was actually, I don't have any headphones. But I just walked over to see if I had the test one. I did a test of this last night to make sure. Hey HC, how are you? I tested this last night, this on my other CNC, not on this machine, to make sure it functioned. The G code was good. And I thought I may have thrown out my sample. But basically what it is, it cuts the smiley face on a piece of wood. Now, since this machine is not working, there is no cutting G code today. Gives you more info for live streams and videos if you want to see some people we're getting. Yeah, I will do. Yeah, okay. No, I'm going to do some more. Once I get this working, I will, because it's DOA. Let's try. I know I'm trying the same thing over and over again, but I might get lucky, and it might come on. Maybe. But I'm guessing there's a short in there somewhere, because the light says green, but when I turn on the power, it's actually very, very faint green flash. So I think there's something shorting out in the board, and I need to do Oh, the windows thing. I'm sorry. Yeah, because they're right beside each other. Oh, okay. Yeah, no, that was yeah. I was because that's because my microphone is right by my computer. So I'm sorry, but yeah, I don't have that sample file with me. I probably the sample test I did in a piece of MDF. I probably dumped it because it was just a piece of scrap test. But it did. With the file does run. It does cut out the smiley face as planned. We just need to troubleshoot this and why it's not powering up. I'll spend a little bit of time today on it, and if I don't get it running today, I'll message our friends at Comgrow and say we have a problem. Houston, we have a problem, and say, do you want it back? Because it will be going back to them because it's no good to me if it's not working. I will do a bit of troubleshooting. I probably will get it going at some point today. I'm sorry. It's not working. Out of my control, guys. Next week, hopefully working. We'll do a live unboxing next week of the Comgrow Z1 laser. No, it's not the brick. I don't think I can. Okay. If I open the Z1, I don't know if the bricks are the same. Jerry, does it look like it's the same brick? Because you have the Z1, and you have the Comgrow. Are they using the same brick? If it is, I'll open the Z1 just for the brick and nothing else. And we'll try that out and see if that makes a difference. If it is, then I can get you a test print. Do you all agree? So I'll only open the Z1 because I normally don't open it until the actual live unboxing. But if you want to try the brick, I can do it. Okay, Jerry thinks it looks the same. Let me get my Z1 and take the brick out of it. And we'll give it a try. Be back in one moment. No. I don't think it's the same, Jerry. The Z1 has a 4 amp. This is a 5 amp. I don't think it'll work. I don't think it's got enough power. No, the power brick has no switch because it's a dual power. So no, this doesn't output enough power. It's a 5 amp, and even the connectors are different. Yeah, the DIN connectors on the end are different. Well, let's try it. I don't think it'll work, but let's give it a try. But that has got a much heavier cable because it pulls so much power. So let's try it. I don't think it'll make a difference though. No. Plug in my hand controller. But I have a feeling it won't be enough. I have a feeling there's something shorting out somewhere. Let's try. No. Definitely not. So it is in the system. Sorry. Nice try, but this will have to go back in the box for a partly live unboxing next week because I've already opened the box for the Z1 just for this. Yeah, the light didn't even come up fully. Yeah, so it's probably the same issue. I will be doing. So I will unbox the Z1. No smoke will come out, just lack of power. So there's a good chance this machine will be going back for a quick replacement. And we will do another unboxing of this machine But no, actually, do you want to do if I get a replacement? Do you want to do a live unboxing, or do you want me to just do videos of it working? If I end up having to replace it, what you guys want to do? Let me know. Packing tape. Yeah, something is loose. I'm pretty sure something is loose somewhere inside, which is why it's not working. So what do you want to do, guys? Dipole it up and no smoke. That's great, Zolan. So if I get a replacement, which will probably take a week. Do you want me to do both? Okay. Because I did the unboxing and assembly here. What I might do is I might end up doing one in the future. Or if I do get to the other one, I won't assemble it. Or I'll assemble it off camera maybe. And test, because I don't want to do another one of these. It's not working. I'll do a test, and then after getting it tested and I know it functions, might do a stream of showing it working. How is that? Or a live stream, or I'll just do videos. I can do either. But yeah, right now it's DOA. I'll have to do some. My multimeter will be busy this evening doing some checking to figure out where it's gone wrong. But I'm almost sure it's either the power switch. Because there's no power getting to the board. So if this power switch was good, the power would get to the board. It's not getting to the board. Actually, Jerry, do me a favor. On the undercarriage of yours, because you have one of these, take a photograph up close of the wiring around the switches and where the power connector plugs in. I want to make sure that they've wired this correctly. Oh, what happened there? My video went out. One moment, guys. Oh, my video went out. I'm sorry. My camera had a moment and it decided to close the shutter. Can you see me, guys? It might have been a low battery, but I wasn't running on battery. I just reseated my mains connection and it came back on again. So, guys, let me know if you can see video. Hopefully. That's a first for me. Everything, you can all see me. BMX moment. Okay, let me know if video is back. This was fun. Be nicer to have this running. If I get it running this afternoon, I will actually go out and Jerry. No, you're not having a hangout today. I'm having a rough day. You are right, Dennis. It's been a rough day because the machine's not working. Printer goes out. Oh, it said battery low. Okay, so for some reason it wasn't seeing the power. But when I reseated the power adapter, it came back on again. So you can see me. Let me know, guys, that it's working. I know we're about to wrap up. Yeah, well, I have 24 DC on the second power supply, and it's set up the same way, Dixon. Problem is, it's not outputting enough amps. So, and even if it was 4 amps, if we're over 5 amps, it should still feed correctly. But what's happening is the power is on the main break is coming on, and when I turn on the power supply, the light goes from a bright green to a barely flashing green, and flashing on and off a little bit, and it's barely visible. So I think there's something wrongly connecting the printer that could be in the CNC that's actually shorting out. Okay, great, Jerry, thanks. So I think there's something shorting out in the CNC, and I need to do a bit of troubleshooting on that this evening, or this evening, to see if we can figure out what's going on. There's no message. There's nothing. It's not powering up, so there's no message. I'm not getting power to the main board. I even checked power at the main board, so I'm almost sure it's where the power connects in at the back of the machine. That's not right, and it's not getting power because there's no power hitting the main board. But I will do a bit of troubleshooting of it, and I asked Jerry to send me an image of his setup, of his cabling setup, where the power and the power switch on the inside of the machine are on the back of the machine. Just, you know, Jerry, I'll just show you here what I'm looking for to make sure that this is wired correctly. I want you to show me images of this setup back in here. I want to make sure that they have it wired correctly. I have a feeling they don't. And that's probably all it is. Because according to the... Actually, I wonder if it's that. Their power brick says positives in the center. But in here, the center is actually... Yeah, is the power line, yeah. So just send me the wires, the picture of it, Jerry. I want to compare. Yeah, no, there's no... Yeah, it's not jumper switches, no. The jumpers are all in the right position. It's something to do with this area back here where the power is coming in. Something is not connecting correctly. It's either on the power switch itself, which is a possibility, or it's on the way it's wired back to the board. But there's only one way it can be wired, because these are keyed. So I'll look at it later. Sorry guys, can't show you live CNC working because it's not working. So I will look at this afternoon. If I get it working, I will send out pictures. I'll do some short video of it functioning, and I'll explain what I did to get it working. But it shouldn't be like that. It should be just plugged together and function. Let's see, are these right? Yeah, I think this is all right too. Let me see. Just one last. No, that's the only way it'll go in and lock. So, no, that's good. Alright, I'm sorry. We don't have a working machine. And next week we will do the Robo CNC. Or the Z1 laser. I have scheduled for next week. It's sitting over there. I only opened it to get its power brick out of it to test, to see if that would make a difference. But there's definitely no power getting into the board, so it's something to do with the electrics, and I will figure out what it is later on. And it may require a part replacement, or it may require just moving some cables around. It could be incorrectly wired up, but I'll figure it out, and we'll get working on it this afternoon. And I'll get some video out of it hopefully this afternoon. So thank you for joining me, Jerry. Don't forget to send me that photograph, and I will see. We'll hopefully get it working, and if not, it'll be going back to them for replacements. And if so, thank you guys. It was fun. Pity it wasn't more fun that we actually had a working CNC, but you actually cut out this design, because as I said, this design does work, because I had this design working on my CNC, on my other CNC. I tested it last night and it worked fine. It's just that this one won't power up, but this does work. Because I wanted to show you how to zero out your X, Y, and Z on your part, and how to get going on your with your machine. Couldn't show you today, but maybe I'll just grab out my other CNC and I'll show you on the other CNC maybe someday during the week, and run just set up for the same part, and I'll show you how it should work. Or if I get it working, maybe some evening during the week I will throw it up. Now don't forget, Jerry is actually interviewing Loyal Moses on his channel. Jerry, plug the details of your channel and the stream. Yes, Carl, I didn't break it. It arrived broken. Yeah, okay, but Jerry, post out there the link to your interview with Loyal that you have Tuesday night, I believe. So post that out there, because Jerry is interviewing Loyal Moses. Some of you know Loyal from 3D printing, and he has his own channel now over on Twitch. But he's coming on to do an interview with Jerry. And that's coming on Tuesday. And hey Ron, you came on at the very end. We're about wrapping up because the machine isn't working. So check out Jerry's stream, and then on Wednesday night I'll be having a hangout at 7 p.m. US Eastern time on my YouTube. So check it out. If you haven't already followed and subscribed, please follow and subscribe to my channel. And do it also with Jerry. Jerry's out there. Jerry does a lot on the CNC, and his CNC actually works. So he actually has samples of his CNC functioning. I can't do that, but I will later in the week. And then So Tuesday, Jerry. Wednesday, I'm on with a hangout, so you're all welcome to come join me and hang out with us. And then on next weekend, I will do a live unboxing of the Z1. It'll be next Sunday because I have stuff on Saturday to be done. So I don't know. I only opened it to take out a power supply, so I don't even know what's in it. The Z1, I will find out when I open it. Check the picture you sent now. Okay, just 1 second, Jerry. This is on Facebook. Let's see what Jerry sent me. Okay, I'm just checking out waiting for Facebook to open up. You retracted the message? Okay, let's see what Jerry has there for pictures. So that goes there. From the center flagpole. To the left. Okay, that's correct. And this goes over to the board. I'm just checking out the pictures that Jerry sent me. Yeah, no, they look okay. It looks that looks all right. So I maybe the power switch is bad. This is not a Z1. This is the Comgrow Robo CNC that is not functioning. I'm getting power to the power supply, but I'm not getting it anywhere else. So I'm going to do a bit of diagnostics on that later. And hopefully get it working later today. And if I do, I'll do some short videos and I'll post them out. I may even go live again and post out the video of it functioning if I can get it working. And next week I have the Z1, and I will do the live build of the Z1 next week. I did open the Z1 today just to grab its power supply, just test it on this. So it's not a power supply for sure. And I will do that. It was a quick hello. Yes, it was, Carl. But I will do that by next week. Next weekend we'll do it. Next Sunday I will do that unboxing, and we'll get operational with that one hopefully. So DOA machine, fun always. I'll let you. We'll keep you updated on how it goes. Thank you for joining me. It's always fun to have you guys come in and hang out with me. It's I enjoy these streams all the time. You know, I meant the laser off to the side. Oh yeah, it's the Z1. Forgive me. Yeah. It's over there in a box. I opened it briefly to take out its power supply, and it'll be going back in. I won't bother taping it back up because you've all seen me open it already. But we'll get going on that on next Sunday in the morning. And thanks for hanging out with me. Sorry it wasn't more exciting that we actually got it functioning, but maybe I'll get it functioning by sometime this afternoon. I'll let you know what I did to get it working, and we'll share with everybody how it went. Thank you guys for hanging out. It's been great. Hope you have a good day for the rest of your day. The remainder of your evening for those who are overseas, or mornings depending on where you are, and for those of us here in the US, have a good afternoon. And I will see you probably on Jerry's stream on Tuesday. See you on my hangout Wednesday, and also see you on my live my unboxing of the Z1. Same time next Sunday. Okay? Thank you guys. Have a good one. Take care.